let's understand the different types of recursions that we could use in our daily life. And different types of recursions are basically divided as 4 types. First one is direct recursion, second one is indirect recursion, third one is tail recursion, and the fourth one is non-tail recursion. Let's understand each of them in detail. The first one is direct recursion. The programs that we have seen till now are nowhere different from this direct recursion. In direct recursions, what happened is a function calls it itself. It is very simple, like as we have seen previously. Just know the structure of the direct recursion. As we can know, it is a function calls it again. Here we could see the structure of the direct recursion. A function fun is defined. Inside it we call the same function fun here. So it is nowhere different from the past programs that we have discussed. Let's go into something different, that is indirect recursion. Let us say we have fun of 1, then it calls fun of 2, then fun of 2 again calls fun of 1. Seeing these lines, it might be slightly tricky to understand the indirect recursion. Let's understand it with a code. Consider a code here. Function fun of 1 is defined. Inside it fun of 2 is called, and another function fun of 2 is defined. Inside it fun of 1 is called. You can observe that indirectly fun of 1 is calling itself via fun of 2. You could see the case between these two functions. Fun of 2 is defined in the fun of 1 and fun of 1 is defined in the fun of 2. Indirectly it is calling itself. So the third variation of recursion could be tail recursion. If the recursive call is the last thing to happen, then that is nothing but the tail recursion. And we understand the tail recursion here with an example program. Let's consider this program. It has a main, it has another function called as fun. Let's analyze this program using stack to understand the working of this program. We have considered a stack, and activation record of main gets pushed onto the stack. As function fun of 3 is defined here, and activation record of fun of 3 gets pushed onto the stack. And let's analyze the fun of 3 program. If 3 is equal to 0, which is false, else part gets executed. The first statement of else part is nothing but printf statement. It gets printed on the screen. The next statement, return fun of 2, gets executed. Fun of 2 activation record pushed onto the stack. This pattern of analysis goes for different things, like for fun of 2 executed again, 2 is equal to 0, which is false, and else part gets executed again. Printf statement executes and its value get printed, and fun of 1 gets called. Again fun of 1 activation record pushed onto the stack, and fun of 1 gets analyzed, and if 1 is equal to 0, which is false again, else part executes and printf statements get executed. 3, 2, 1 in the output, and return fun of 0. Now fun of 0 gets called. If we can observe that 0 is equal to 0, which is true, then the true block contains the return statement. So the activation record of fun of 0 gets popped off, and return execution returns to the fun of 1 activation record. So fun of 1 resumes its execution, and just the statement returned is nothing but returning statement. So there is no meaning in returning like that. So it just gets popped off. Similarly for fun of 2 happens the same, and fun of 3 happens the same. Finally the function returns its control to the main function, and here also it happens. It just pops its activation record out of the stack. Let's now know about the non-tail recursion, which is a variation of tail recursion. Here you could understand what is the basic difference that we can understand between these two things. Non-tail recursion is nothing but if the recursive call is not the last thing to happen, then such a recursion is called as non-tail recursion. We could analyze this with a program. What I have done is, from the past program, I just swapped the lines fun of n-1 and printf statement in the fun function. So let's analyze this program. Let's consider a stack. Activation record of main gets pushed onto the stack. Fun of 3 gets into that stack. Fun of 3 gets executed. If 3 is equal to 0, which is false, else statement gets executed, and fun of 2 gets called. Activation record of fun of 2 gets pushed onto the stack. Fun of 2 gets again analyzed here. 2 is equal to 0, which is false. Return else part gets executed, and fun of 1 is called. Fun of 1 again called, and if 1 is equal to 0, which is false, else part gets executed. Fun of 0 is called again, and fun of 0 activation record pushed onto the stack. fun of 0 is called if 0 is equal to 0, which is true, return statement executed and activation record from the stack gets popped off. Here we can see here there is some other thing after the recursive function. So we resume our execution and execute that particular line printf %dn. So the value of 1 gets printed on the screen. Similarly for fun of 2, similarly it resumes its execution and prints the value of 2 on the screen. Similarly for function 3, it resumes its execution and prints its value on the screen as 3. Here you could clearly observe the difference between tail recursion and non-tail recursion. That is, in tail recursion there is nothing to execute, it just gets popped off when its execution is over. We could say there is no use for a tail recursion, but when it comes to non-tail recursion there is a bit edge over tail recursion. And similarly the function returns its control to the main function. Finally the activation record of main gets popped off from the stack.